The most successful probe of all time is back after a dramatic event. Voyager 1 is now returning data from all 4 instruments and the mission continues. Voyager 1 has penetrated deep into interstellar space and is providing us with unprecedented impressions from there. But what had actually happened? Why did the probe send garbage data for almost half a year, and what stroke of genius was used to repair Voyager 1? Join us on this cosmic journey. It's back. Voyager 1 is transmitting data from all 4 instruments. It was considered lost. The location of the probe was reasonably clear, but the data had been unusable since the fall of 2023. The NASA Control Center in Pasadena only received cryptic messages consisting of ones and zeros that made no sense. For months the team fought to save the probe. Then came the sad day when NASA announced that the Voyager 1 mission was probably over for good. What a joy it was when the return of the probe was announced just a few weeks later. After drama in the fall of 2023, Voyager 1 began sending incomprehensible data to Earth. Communication, which had worked almost smoothly since the mission was launched in 1977, was suddenly disrupted. Scientists and engineers at NASA were at a loss for months. The gibberish indicated that the scientific instruments on board the space probe were still functioning, but the data received could no longer be interpreted. This caused great concern. More than 20 billion kilometers away from Earth, the probe is an invaluable instrument. Never before had a probe sent data from interstellar space. Naturally, NASA is doing everything in its power to get this veteran of space exploration up and running again. Experts tried to decode the probe's messages to draw conclusions about the error, but even the most ingenious technicians and decoding experts initially came up with nothing. Then came the first breakthrough. A scientist from the Deep Space Network, which monitors the probe's communications, was able to read the message for the first time. Voyager 1 was permanently transmitting a complete imprint of its memory and regulation system. This was good news because these systems are like the heart and brain of the probe. Voyager 1 was alive, but the way it was transmitting data was out of kilter. Despite this realization, further troubleshooting was difficult. The main problem lay in the sheer distance from Voyager 1 to Earth. Radio signals take more than 22 hours to travel the distance in one direction. This meant that any diagnostic measure took almost 2 days to receive a response. Initially, the engineers focused on the flight data subsystem, which is responsible for packaging and transmitting the scientific data. Initial analysis showed that a specific chip within the subsystem may not have been functioning properly. Months passed with intensive testing and attempts to find the exact cause. Engineers at NASA worked tirelessly to develop and test various solutions, but it all came to nothing. For a while it seemed that all options had been exhausted, and there was growing concern that Voyager 1, after almost 5 decades of faithful service, might finally fall silent. Morale within the team sank, and the prospect of humanity losing contact with its most distant ambassador in space was hard to bear. Millions of fans of the probe around the world were feverishly awaiting the news. NASA kept scientists and space enthusiasts alike up to date, posting attempts, sharing progress, and candidly admitting disappointments. In February 2024, NASA's mission manager announced in a public statement that the mission was slowly coming to an end. There was great sadness, but there was also hope. Despite the setbacks, some engineers did not give up. Tips and ideas on how to bring Voyager back to life continued to come in from all over the country and from experts worldwide. NASA decided to carry on and pursue an interesting new approach. The idea was simple: the faulty code was redirected to another section of the SDS. This was not without risk, as it could have meant permanent radio silence. The process required precise coordination and timing. Every signal sent to Voyager 1 had to be carefully tuned to avoid causing further damage. On April 20, 2024, the unbelievable finally happened. After months of effort and countless hours of hard work and dedication, Voyager 1 was once again sending intelligible data to Earth. Can you imagine the joy and jubilation at NASA when the data received made sense again? It got even better. All 4 scientific instruments on board the space probe that are still relevant were fully functional again. This triumph catapulted Voyager 1's mission into the league of absolute space legends. The restoration of communication with Voyager 1 was not only a technical success but also an emotional victory. All the scientists and engineers involved around the world rejoiced. After the problems of 2021 and 2022, this was the second successful repair on a probe that is more than 20 billion kilometers away and has been flying through space for more than 45 years. The story of Voyager 1 will continue, and who knows what secrets interstellar space still has in store for us. The incredible continuation of Voyager 1's mission is unbelievable, but this probe could continue to send us data for another 10 years or so. The batteries will probably finally fail in the mid-2030s. Following the successful resumption of the mission on April 20, 2024, Voyager 1 is now once again at the center of interstellar research. The space probe has already provided historical data on the outer planets and the border regions of our solar system. Now it's penetrating ever deeper into the infinite expanse of interstellar space and exploring unknown regions. The scientific goals and expectations lie in particle measurements from interstellar space, as well as research into cosmic radiation and magnetic fields. These data help scientists to better understand the structure and composition of space beyond the heliosphere. Our Sun envelops itself and its planets in a protective bubble of particles and magnetic fields. Behind this bubble, a completely different kind of space begins. Plasma waves are particularly interesting. These waves should give us information about the density and movement of the interstellar medium and help us to understand the entire universe a little better. As Voyager 1 is the first probe to explore this region, the knowledge gained will be invaluable for astrophysics. After all, this medium makes up the largest part of the galaxy. Beyond the borders of our Milky Way begins the even more vast intergalactic space. We do not know what is really going on in interstellar space. All of our knowledge to date has been based on estimates, calculations, and assumptions. Science has confirmed some of these assumptions, but others have turned out to be complete errors. Voyager 1 proved this once before when it crossed from the heliosphere into interstellar space. Scientists had imagined the threshold to be quite different, and interstellar space surprised them with a higher particle density than expected and indefinable plasma flows. Who knows, Voyager the 1st of May even find evidence of previously unknown objects or even exotic forms of matter. Such discoveries could have a revolutionary impact on our understanding of the cosmos. One particularly exciting possibility is, of course, the discovery of traces of extraterrestrial technology or signals. What is certain is that Voyager will continue to fly for hundreds of thousands or millions of years after the end of radio contact. In the event that the probe encounters other intelligent civilizations at some point, it and its twin probe Voyager 2 have golden records on board with a greeting from humanity. When and whether these messages will end up in the hands of other life forms is truly written in the stars. It will take Voyager 1 a whole 40,000 years to approach the nearest star on its road to the Voyager 1 Hall of Fame. Can you imagine how long the data and achievements of the Voyager mission have been with us humans? When this probe was launched, many of you were probably not even born yet. Generations of scientists worked with the fascinating discoveries of Voyager 1 and 2. In honor of this extraordinary mission, let's take another look at its greatest achievements. In 1977, the Voyager 1 probe launched from Cape Canaveral spaceport in Florida. After several swing-by maneuvers and crossing the asteroid belt, the probe reached the gas giant Jupiter in 1979. Voyager 1 analyzed the upper layers of Jupiter and took detailed pictures of the marbled surface and the Great Red Spot. Next, the probe stopped by Saturn. The flyby revealed the complex structure of Saturn's rings and Titan's atmosphere. Voyager 1 then began its journey to the edge of the solar system, while Voyager 2, after its initial mission to Jupiter and Saturn, visited the outer planets Uranus and Neptune. One of the most iconic images in the history of space exploration was taken from a distance of 6 billion kilometers. Voyager once snapped the Earth as a pale blue dot to say goodbye. That was in 1991. Then it was almost 20 years of silence around Voyager. Most of the equipment was switched off to save power, and the probe steered through the Kuiper belt and further out to the edge of the solar system. Towards the end of the heliosphere, NASA switched the equipment back on and Voyager 1 returned to providing data. The researchers wanted to know what the magic threshold between the sphere of our Sun and interstellar space is like. In 2012, the time had finally come and Voyager reported an astonishingly jerky transition. This proved that our Sun builds up a kind of solid vertical threshold at the edge of its sphere of influence, which acts like a thick protective skin. We have now been receiving data from interstellar space for 12 years. for instruments are still in operation. With its plasma wave instrument, Voyager 1 measures the density and temperature of charged particles, which are rarer in the interstellar medium than within the solar system, but carry completely different charges and probably also have different physical properties. The cosmic ray instrument detects high-energy cosmic rays to analyze their composition and, above all, their origin. Strange rays could, for example, provide clues to objects or structures that we may not have been able to see until now because they lie in complete darkness. The magnetometer, which measures the strength and direction of the interstellar magnetic field, can also provide us with such clues. The probe also detects low-energy particles with the particle detector. This is important to determine whether interactions between the solar wind and the interstellar medium can still be found further out in space. Thanks for joining us on this cosmic journey. Tell us your opinions in the comments section below. Don't forget to like, subscribe, and click the video on your screen for more mind-bending content. Until next time, keep gazing at the stars. This is Cosmic Inquiries signing off.